My name is JIANXIONG Zhou, and I'm a second-year PhD student of Northwestern University. My supervisor is Professor Ying Wu. The paper I want to report is titled Temporal Feature Enhancement Dilated Convolution Network for Weakly-supervised Temporal Action Localization. Weakly-supervised temporal action localization is to locate the start and end timestamps of action instances in an untrimmed video and classify them. It only requires video-level labels. Our paper aims to address two limitations of WTAL: the short temporal span of snippets and the inappropriate initial features. This figure demonstrates some examples of errors. A complete action instance usually covers a relatively long temporal span, while a snippet is unable to observe the full dynamics of the action instance. Thus, we use TFE-DCN module to enlarge the receptive field and captures temporal dependencies between snippets. Another limitation is that most WTAL methods directly use the RGB and optical flow features extracted by pre-trained models, which are trained for trimmed video action classification rather than WTAL. Thus, we use both TFE-DCN module and the Modality Enhancement Module to enhance initial features. Our method consists of 4 parts. First, pre-trained feature extractor that outputs RGB features and optical flow features. Second, TFE-DCN module that generates enhanced optical flow features and temporal attention weights. Third, Modality Enhancement Module that generates enhanced RGB features and spatial attention weights. Fourth, the classifier and element-wise multiplication that generates the temporal class activation sequence and suppress the TACS. We apply the TFE-DCN module to effectively use temporal information and enhance optical flow features to make them more appropriate for the WTAL task. This module consists of a K-layer diluted convolution network to enlarge receptive field. We feed the optical flow features XN flow into the first flow layer, and the dilution value is 1. For the Kth layer, the process is formulated as below. The enhanced optical flow features XN flow star is obtained at the last layer. Finally, we use the module to generate temporal attention weights AN flow. The Modality Enhancement Module is to enhance RGB features XN RGB with the help of the enhanced optical flow features XN flow star. We use a sharing convolution layer to make width distributions of two modalities more approached. The step improves performance and is different from existing channel attention methods. Then we use the module to generate spatial attention weights AN RGB. We conduct experiments on two popular WTAL benchmarks, THUMOS’14 and ActivityNet 1.3. The evaluation metric is the MAP under different IOU thresholds. We observe that our method outperforms all previous WTAL methods on both datasets. The results demonstrate the outstanding performance of our method. Thanks for your attention and your time.